Okay, hello everyone. Welcome to third class of this course. My name is Min Sang Yu. I should have changed my name. Okay, my name is Min Sang Yu, and I'll be the instructor for today and the Thursday's course. And I'll be going over some machine learning parts, and then I'll be going over example projects that has been we could found in the online. On Thursday, I'll be going over that project, and today I'll be going over some of the machine learning concepts and examples. Um, I myself did my bachelor's in USC as a economics and mathematics major, and for my master's, I did my applied data science also in USC, and I recently graduated in last December. So let's get started with the PowerPoint. Can everyone see my screen, the PowerPoint screen? Okay, all right. So today we'll be talking about Python for machine learning. And our brief outline is what is machine learning and what types of machine learning techniques are there. And there will be a brief Python demo for some of the machine learning techniques that we'll be talking about today. Um, so machine learning. So right now in the markets, there is a lot of news stories um, about AI, machine learning, or even deep learnings. What are they? So among these three, machine artificial intelligence is the biggest concept, which a program that can sense, reason, and act and adapt. So by the word artificial intelligence, we are trying to teach a computer program to think like human, which is an intelligent part. So we're creating an intelligence, uh, which artificial word tells us, and machine learning. Oh, sorry. Briefly talking about it is algorithms whose performance improve as they are exposed to more data over time. So specifically, we're giving lots of data to a machine so it can learn and create an algorithm. And in the future, we use that algorithm to predict some kind of any kind of phenomenon. And a deep learning is a subset of machine learning. It's like one particular type of machine learning in which uses multi-layered neural networks learn from vast amounts of data. So I don't know if you guys have seen like neurons, how it's connected to each other, some kind of image like this. So it gives lots of data. So it will try to learn from it and then create uh, a result from it. So machine learning, sometimes we don't use a lot of data, although it's better to have a lot of data. but some machine learnings don't need that kind of much data. But deep learning, we use a lot of data, like healthcare data and stuff. So, what is machine learning? Is the study and construction of algorithms that can learn from and make predictions on data. The predicting part is very important in machine learnings. And excuse me. And we optimize a performance criterion using example data or past experiences. Well, data is a past experience because it's created by them. And the role of statistics in machine learning is building a mathematical models and inference from a sample. So most of the machine learning statistics is very important because if we were to predict something, it's about the probability. So using the statistics and the example data, we're predicting something. We're trying to predict something with a high possibilities. So we don't want to mess up the results. The role of computer science in machine learning will be creating efficient algorithms to solve the optimization problem and represent and evaluate the model of inference. So last week, you guys learned using Python. Python is a very easy tool to use, but it gets kind of hard to use them when we are using a lot of computing powers. For example, if we're using vast amount of data, such as in the deep learning that we just talked about, um, it's kind of it's kind of give you a hassle by slowing something down, and if your code is complex, it's gonna take a lot of time. Although it's gonna work, but it's gonna take a lot of time. So in machine learning and AI development, people try to optimize the algorithms so they can speed up how the codes are running and how each learnings are done. So if I don't know, like what kind of majors you guys want to pursue in the future, but if you're going to work on some of the data science fields, you are going to learn how to process as fast as you can, how accurate as you can. Um, I mean, if you have enough funds and enough money to give like strong computing powers, it's gonna matter less, but with limited amount of um resources, you will have to optimize your codes so it can run as fast as you can. So why learn? So machine learning, we're teaching the machines so they can learn, is programming computers to optimize a performance criterion using example data or past experiences. Um, there's no need to learn like how to calculate the pi rolls because you just input something and you just calculate. There's nothing to predict or you don't need the example data. You just code so that if you input something, that it just spits out something. Learning is used, for example, when expertise does not exist, like navigating on Mars, or human tasks that needs to be automated, self-driving cars, like Tesla, recently launched. I don't know if they actually launched. I think they're still testing, but they have their self-driving taxis. I think they use the Model Y. Um, and then humans are learning is used when humans are unable to explain their expertise, like speech recognitions, um, and there needs to be a solution changes in time, routing on a computer network, and the solution needs to be adapted to particular cases, like user biometrics, like your fingerprints or your eye recognitions and stuff. So we're trying to So for example, like in solution changes in time, if there's variations, if we taught the machines, if the machine learned properly, then it can adapt to changes easily. In the past, we would have to like change everything, like the machine, the settings, and all that, like um, studying the data. That has to be done again all the time, but the machine learning helps us to do that with the previous example data. And then for the future, it's going to help us to predict. The traditional programming versus machine learning. The traditional programming, or like, for example, I don't know how much you went with the previous Python classes. The basic of the programming was we put the code, we put the programs, like set the rules, and then we input the data. And then if we input the data, the program will read the data and then it will give you output as it was told to. But the machine learning, we use the output from the past experience or the data. So here it says labels and the ground truth, which is the same concept. And we put the data and we create the machine learning. So with the output, we create the machine learning algorithms, and then if we put the input data, it's gonna generate set of rules and patterns. So machine learning is about predicting the future based on the past. So in the past, we have a training data. The machine learns from it and it creates a model or predictor. In the future, we have a testing data. So we call the past data as a training data, and we will call the future that we try to predict as a testing data. We put the testing data into the model, and it's gonna predict and give you results. So examples of machine learning here, we have training data. So I guess this is housing prices. We have a one bed, one bath. Year is 1980 with 140K. We have three beds, one bath, and it's done in 1990, 240K. And then all these, we input this training data into a machine learning algorithm. We train and we create a function. So algorithm function, pretty much the same thing. And then we put the live data. In this case, we don't have the price. So we want to predict the price of these housings to these conditions. So two beds, one bath. If it was built in 1985, what would be the price? So we put the live data into the function and we have the predicted price. It may not be correct. It may be correct, but a lot of cases we could use this as a guidelines to Like in the market, how much would this be? If it's under 90K, then if it's cheaper than that, then we're good with it. If it's more expensive, we need to investigate on it. Why is it? What will be the reason for it? There will be a exterior reasons why it's more expensive than pre-price. So just looking at this case, we only put three features, beds, bath, and ear. So in the real world, there's gonna be a lot more factors that influence the price of the housings. So um, we cannot trust or we cannot 100% trust on these algorithms, but it can give you like starting points on like investigating on this kind of problems. So types of machine learning methods. Um, i- is there any questions so far? You can always interrupt me, raise your hands, or like you can speak out. Okay. So there's several types in the machine learning: supervised learning, unsupervised learning, reinforcement, generative network, and then natural language processing. So supervised learning is so the word itself is supervised. So someone is trying to help you. What's helping in this case is that we're helping the machine to learn something by giving them the actual data. So in our previous example over here, we have a training data so that with the bad and ear, we have the actual result, the actual data, the prices in this case. So in a supervised learning, we give a data that has a label that like the actual prices so that it's gonna learn from it and then it's gonna give you a result. So classification is we're gonna talk about in the next slides. We're classifying something, for example, if it's bad or if it's good. Um, in a healthcare, like if you have these symptoms, then you'll be positive. If you have these symptoms, you are negative. Some kind of that. Um, regression is also another type of supervised learning. Um, if you guys have learned statistics, I'm pretty sure you have um, heard about the linear regressions. So regression, we use them when the data is numerical values. So if it's continuous, then we use the regression methods. Unsupervised learning, by the word unsupervised, we don't give a data that has the actual result. We only give unlabeled, we call this unlabeled data. So through them, it's gonna do a clustering, a grouping. So it's gonna group a data points that shows a similar aspect. So in this case, it would be better if this image was with different colors. So let's say all these were reddish colors, then it's gonna group them as reddish colors. And if it was greenish colors, then it's gonna group them. So if without the actual labels, it's gonna group them with a similar group of data points. And association is kind of similar concept. Reinforced learning, excuse me. Sorry, I'm currently in Korea and it's kind of morning right now, so my throat is kind of funny. Reinforcement Reinforcement learning is training data. Training data is dynamic like playing a game or driving. So it's gonna keep learning as it is proceeding. For example, playing a game, I'm gonna show you a video in the next slides too. But as it's keep on going, it's learning, 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 and then in the end, it's gonna give you hopefully a perfect, but never that there's never a perfect learning, but it's gonna give you as close to perfect as possible. So, for example, in driving, if you're constantly driving, you confront a lot of cases. So something might pop up. You can, or there be car crash. There can be lots of cars in the roads. So as it's going, you learn from it. You see a car crash, you try to avoid it. And because in a real life, there's a lot of cases. There's no single same cases when you're driving. Like different roads, different people, different driving, different cars, and all the stuff. So you keep learning from it as you are training. The generative network, it's what people can face really easily nowadays. Deepfake or your voice, mimicking your voice, all those all those videos, creating them is a generative network. So you give it a training set, learns to generate new data with the same statistics as a training set. Few months ago, there has been a lot of cases using ChatGPT to create Ghibli, the Japanese the animation. You provide your picture and it's going to turn your image into the those kind of animations. Those kind of methods are using the generative network, and then natural language processing um, is studying the machine learning in languages. So it's used a lot in ChatGPT because it's talking between people. Although it may seems easy for us to speak something, to have a conversation, it's a very complex concept in machine learning because machines needs to understand what we're saying. Not all people speak the same way. They have a different grammar, or you might provide a wrong grammar sentences. It's the ChatGPT still understands that. So those kind of concepts are using the natural language process. So the classification example, as you can see on the right side, there's 12 images. One is a blueberry muffin, and one is chihuahuas. For us, it's very easy. Muffin, chihuahuas, muffin, chihuahuas. But if you look at it as a computer's perspective, they have three dark dots, chihuahuas and the muffins. They have yellow surroundings, both of them, and they're kind of round. The muffin's are round, and Chihuahua's face is also round. So we want to create an algorithm that if we input some image, it's gonna say if it's a Chihuahuas or blueberry muffins. Can anyone would guess, like what features or what factors would affect our algorithms so that it can predict if it's a muffin or if it's chihuahuas. Like you can give me any ideas. There's nothing wrong, right or wrong, because we haven't actually tried it for ourselves. So like anyone has an idea on like what could affect it. So my guess will be maybe the paper wrappings around the muffins. Like Chihuahuas don't really have that. And then this can maybe it's just an idea, but it can affect our algorithms. If it has it, then it's a muffin. If it doesn't, then it's a Chihuahua. Maybe some Chihuahuas may have like clothings on it, then it's gonna predict wrong. Or maybe Chihuahuas have like steady distances from each dark points. So between their eye, between their nose, maybe they create some kind of a triangle. Over here is gonna try a triangle here too, and then. And with our eyes, it may be hard for us to look, but there's a holes in their nose, so that can be a factor for our algorithms to decide whether it's muffins or. So there can be a lot of factors in algorithms. So in the future, if you're guys performing a machine learnings, then um it's easy to imagine first to think. So these features will be important and these features would not be important. Then you spend lots of less time trying to teach our machines because as I said, as the data gets bigger and bigger, it's gonna take you lots of time. For example, when I was doing my master's in USC, they gave us a project, and with my laptop, I wouldn't say it's a cheap one, but with my laptop when I wanted to run something, I had to run it and then go to sleep and come back in the morning to see if it's still running. So that kind of problem comes up in the future too. And then if I knew with what features mattered less, then it's gonna shrink a lot of data and then it's gonna take a lot of less time. And image classification, Tesla's autopilot. If you're driving a Tesla, it gives. I don't. I haven't drove Teslas yet, but I don't know if it's automatically changes the lanes, but it's gonna read the ground. It's gonna see what is the lane. You're gonna see the straight line, dotted lines, and the image here shows us you need to detect people, you need to detect the lights, the signs, the cars. So it's gonna classify as this is a car and this is a human. After this Thursday for your project, the professor said that you guys will be doing some kind of this kind of object detections. So we're detecting this object like this. So we are going to provide sample data, sample codes, so that you guys can easily follow. But that kind of The project kind of shows what classification is. The object detections would not be like classifying something. This is a car. This is, or maybe you can. It depends on if you're going to label each of them differently or not. But I think you guys might be doing a truck detections. So in this case, we just need to say if it's a truck or not. So that's kind of the example of classifications. These two were image classifications, but if you go to document classifications, um, emails, articles, comments, for example, the comments, if you go to a Reddit and you scrape all those Reddit comments, and then you want to find out, for example, you go into some kind of dramas or some kind of movies and you want to see if the comments are positive or negative or not. So if someone says I like this, then it's gonna be positive. And if someone says I don't like this, I don't. So don't is kind of a negative reactions, although it really depends on the words that it's connected to. So don't itself will be a negative, kind of treated negative. Neutral, you don't have opinion, something like that. Uh, then it's gonna read the comments and says this is like 60% positive. This is 100% negative. This person really doesn't like the movies. And the emails, if you go into your Google, it kind of divides the emails on each categories if it's personal, social, or marketing. Um, articles is going if you put in the article, you ask them what kind of article this is, and it's gonna say if it's politics, oh, this is a business article and sports. So in this kind of, for example, in articles, we just put in words that are commonly used in the politics. And we label them as if you have this words a lot, then it'll be politics. If you have this words a lot, then it's gonna be sports. So th- as we said, the classification is a supervised learning. So we will be giving data with labels. So this word is politics. So the politics will be the labels and the words will be the features. And then regressions, I will just briefly say that these regressions, we use them when the datas are numerical, or we say the continuous. So it's from 0 to 25 to 200. So there's no gap between them. So it's 0, 1, 2, 3, 4, and up until 200. And the car prices also, the labels here are numbers. So 5,000, 10,000, it goes up. So it's a numerical value. So we use the regressions. The linear polynomial decision tree and random forest. Decision tree and random forest is gonna try them in the end of this slides. Just briefly saying decision tree is just deciding, and then random forest is also a similar concept. And then understanding variables, income, and education. We want to see the connections between them. If you have a high income, does it mean that you have a higher educations? Or vice versa? Like if you have a higher educations, does it mean you have a higher income? GPA and SAT scores. If you have a higher GPA, do you have a higher SAT scores? Does it have a positive relationship? So higher GPA, higher SAT scores, or negative relationships. It doesn't make sense, but higher GPA may actually means lower SAT scores. Making predictions, e-commerce sales. So we, if it go by the years, then and we have a sales, then if we have a positive relationship, then it's gonna say as the year goes, it's gonna have higher sales in the end. Or if it's a late negative relationship, then as the year goes, it goes a year and sales doesn't really match, but that's kind of concept. You finding a relationship between them, the car prices and the loan eligibility. So you put in lots of features. So like loan eligibility, your income, your past loans, your credit scores, all these kind of features will be used to predict your loan eligibility in the future. Clustering is a unsupervised learning. So it is basically a collection of objects on the basis of similarity and this similarity between them. So if you look at this, it doesn't have a color right now because, as we said, unsupervised learning is using a data which is unlabeled, but it's gonna group them with the similarities. It really depends on the datas, and then group them so we can have a grasp idea and like which data points are similar and which data points are not similar to each other. So clustering is very much important as it determines the intrinsic grouping among the unlabeled data present. So in a real world, it's really hard to get the right data. Always the data itself is a problem, and then you're gonna spend a lot of time cleaning the data, getting the data. Getting the data is the hard part. Cleaning the data to test it, like if it's the right data, is it really meaningful? But in a lot of cases, there's not gonna be a label too. Then in those cases, we'll be using a clustering method. One example is streaming services. Streaming services often use clustering analysis to identify viewers who have similar behavior. Potential data to look at: minutes watched per day, total viewing sessions per week, or number of unique shows viewed per month. There's no labels to it. Um, you just have a similar people, or then maybe in the future you can recommend if you show this kind of features, then you're gonna fit to this. Company can identify high usage and low usage users and know who to spend most of their advertising dollars on. So maybe you can advertise hardly on to the people who watch a lot, so they will spend more money. Or you can promote some kind of like maybe cheaper membership to people who use less. So you can um, pull them to use your services so that they can use more. So reinforcement learning, and we said that it's learning as it's going. So I don't know if you guys remember this AlphaGo. So Google created reinforcement learning algorithms so that you can play this game called Baduk in Korea, in Asia. um, with the most famous player called Isidore, and then they competed each other. So, and among the 7 games, he was able to win just one game compared to this machine or robot, we'll say. And at that time is sensational because none of the players would ever beat the robot, the machine, but he was able to do it. Um, it's kind of fun too, even though you don't know what this game is. You can just go and still watch the reactions of people watching that. Um, they broadcasted it as it goes, so it was kind of interesting too. And this is the example of DeepMind. Pause for a second. Yep. So this is one of the examples for the reinforcement learning. So the model, the human model or the spider model, it's walking as it goes. So you're telling it to go to that directions. But as it's going, it meets the obstacles. And then by repeating, and repeating, it learns itself how to go over that. So you bend your knee, you put your one of your leg up to the obstacles, and it goes over. So they simulate this hundreds and hundreds of times so that it's gonna slowly learn. The video only shows the result, but if you see that tedious job, then it's gonna first step, pause, go back, is that what take a 2 steps and pause. Or maybe it can give you a like brief um starting points. It teaches you how to walk first, but it doesn't teach you how to go over or go around the obstacles. But as it's running and you face the wall and you just step over it. So that's how you learn from it. if you are interested in creating a robot, then it's gonna show how it's learning. They tested just by walking. You push the robot, you see if it's gain balance, remain the balance. And the video also shows that you tilt the ground and you want to see how you keep the balance. So you put in the basic physics rules into this algorithms, and then um, the figure itself learns how to balance itself and stuff. Okay, and then next slide. Generative adversarial network. It's we provide a data and it's gonna generate another images. So this is using a DALL-E, and then we provide the image and it gives you a lot of facial emotions. This one too, it turns your head. Um, you look somewhere different, and oh, that's so this smiles, closes their mouth, they open their mouth and stuff. And then for this one too, um, mm, so as you can see here, so that video shows one of the examples of generative AI. It uses the voice data and the facial data of this actor, Morgan Freeman. There's lots of movies, so there'll be a lot of data, so they can easily train the machine to create a generative image or a video. So there has been a lot of crimes regarding this general networks. So if you guys are using this or trying this on your own, you need to be cautious on how you're using um, these AIs. There's a lot of um, you can use them very usefully too. It can be fun too, but just yeah, use it with cautious. Okay, so the core concepts is machine learning. I'm not gonna go deeply into this. I'm just gonna give mention this because if I really want to go deeply on this, it's gonna take a lot of time. So just in the future, you're gonna say, "Oh, I've heard about this." Then it's gonna kind of help you like get interested in, oh, so this is important, so I need to study deeply on this. Features and labels, as we said, features are the data points, the factors, what causes something. So in the housing, um, how many beds there are, how many how many what were there years, what year was it made, and then labels will be the results, the housing prices. Overfitting versus underfitting. So overfitting. So when you're doing a machine learning, let's say a housing prices, we give the only the data in Los Angeles. Then and then we try to predict um something in Los Angeles, then we're gonna give it like 100% correct, right? Because we are giving the Los Angeles data and we're trying to predict the Los Angeles data. But it's not gonna give you a correct answers if there are variations. So if your data is not random or if it's trying to learn from only a specific group of data, then it's not gonna be flexible. It's gonna give you the results only correct to those groups only. So that is overfitting. So you're trying too much to be perfect so that you're fitting every concept into it. And then sorry, let's try it again. So overfitting, so forget what I just said. So overfitting is giving too many informations to the machines. For example, the housing prices. Um, like I said, there's lots of factors into that affects the housing prices. If you give too much information, you just try to teach put everything into that machine, then it's gonna be less flexible. So that's called a overfitting. You're fitting too much of it. And underfitting is you're giving too little information on some kind of you're giving too little features so that the machine didn't really learn anything about it. Bias variance trade-off is a similar concept. Bias is leaning towards something too much. So it doesn't give you a proper result that is outside those groups. Variance is you have lots of groups. So bias and variance is kind of opposite concept that if it's too biased, then you don't have much of variance. If it's too various, then you don't have the bias so that it doesn't give you a proper predictions on something. So either way, if it's too biased or too opposite, then it doesn't give you the higher probability answers. Cross-validation is used when we are trying to teach our machines. So let's say we have 100 lines of data. We don't use all these 100 lines to teach the machines because then we don't have, let's say, we put our data into this, like let's say GPA and SAT scores. Then if we test it on ourselves, and let's say how many people are there here right now? Maybe two, three, four, 12 people here. If we put 12 people data into a machine, then if we weren't, let's say we're testing on my GPA scores, and then we try to predict an SAT score. If we use all these 12 people and then use my data, then it's gonna be correct because they used my data too. Then how do we know that this algorithm will be correct or not? We cannot test it because all we have is our this 12 people data. But if we use one of our information, then it's gonna be predicting 100% right because we used our data. So what we do is usually 7-3 ratio or 8-2. We use only 80% of data or 70% of the data. And then we create an algorithms. Then we use the other 30% or 20% as a testing data, which means with the with 70% of data, we created an algorithm. We try to see if this algorithm is effective or not by using other 30% of the data. Does that make sense? Or does anyone have questions about it? No? So because we only have a limited number of data, we want to be sure that our algorithm is correct. So we use only 70% of the data, and then we try to test it with a 30%. The meaning by testing it, because among these datas, the 30%, we also know the result. So when we test the data with the algorithm that we created, we will know that if it's correct or not. So by on the next line, it says evaluation matrix. We will try to evaluate if our algorithm is good or not by testing with other 30% of the data. So we say it's cross-validating because um, we can mix up the 70% and 30%. So we can just pull something here and then put something in the testing data again. So we try it again, then we see which 70%, which group of 70% creates the best algorithms. So evaluation metrics, there's a classification, accuracy, precision, recall, and F1 score. It's pretty much straightforward. Like accuracy is how much it's correct. So we say we test it with other 30%. So if we have 100 lines, then there will be 30 lines. So among 30 lines, how many classifications were correct? If it's precisions, it's called like if it's saying, let's say classifying true or not. Let's say you say something is true, but if it's actually true. So something like that. You could go deeply into it. There's a lot of tutorials on this evaluation metrics too. So you can try to read one by one. It's pretty straightforward, so it'll be easy for you to follow. Regression is mean squared errors, R squared scores. So these you can see them easily when you're learning this statistics. And then these kind of scores are also used for evaluating if our algorithm is correct or not. So um different matrices shows different points of the algorithm. So if you study them and then use them in appropriate situations, then it's gonna be helpful to create a better algorithms. Okay, let's take a quick break. How long was the break for the last classes? 10 minutes? Okay, so then we're gonna have a 10-minute break and then come back at 8:10. Okay. Is everyone back? Right. Does anyone have any questions so far for the previous slides? Okay, that's good. All right, let's go on to um, so our next slides shows the parts of codes. So I'll just go over with the actual codes in the Colab. All right, can anyone see my screen? Okay. All right. Okay. So I'm gonna use thing called a Colab. I'm pretty sure you guys used the Jupyter Notebook for the previous classes, right? For the Python classes. It's pretty much the same thing that you just use it online, and then the features are same. Only thing different is that it because you're doing it online, there's things like downloading a library, um, reading a file that can be a problem. But I, th- I believe that the Google Colab has the libraries that are commonly used by people already installed. So you may not need to install the libraries. So for example, like this, um, you try to run it, and then if it doesn't have a problem, then you're good to go. If it does have a problem, then you may need to download some of the libraries. Let's start with this decision tree. So I think I posted the demo codes in the drive. It's in the lecture 3 demo. You can just download these three without the collab and then run it on your Jupyter notebook. Just be cautious that you are putting these three datas into the same folder so that the to the path to the data doesn't mess up.
Means
In
I'm
my case, I know. Sorry?
um I was just wondering, do all of you guys know how to use Google Colab and Jupyter Notebook? Yeah, we're all good. Okay, cool.
All right, cool. So you can just always ask me a question if you don't understand anything. So decision tree. Decision tree was mentioned in the slides too. Trying to find where it was. It was um, yeah, it was in the 13th page. It's under regression. You can go into the link here and then read about what the data is about. I'm gonna skip that for now. We'll be building a decision tree model. So we load all the libraries from pandas, sklearn. You're gonna use this sklearn a lot in machine learning classes because the decision tree classifier, train split, and matrices. Um, from the sklearn library, we're gonna import these functions. So run that. Take this time. Okay. For me, because I use the Google Colab, I'm gonna use. I need to do this. Is anyone using the Google Colab right now, or are you guys trying on the Jupyter Notebook? Jupyter Notebook. Okay. I mean that's gonna be easier for now, but I'm just gonna use.
Wait, how do I use Jupyter Notebook?
Okay. Then you can skip the step because I'm doing this because I'm doing using a Colab. And
Okay.
then your path will be similar to this line, because if you downloaded your own datas and put it in the same folder, for me, I'm gonna use this path because if I just explain it a little bit, this Google Colab will mount the drive, the Google Drive that I have, and then put it in a file like this. So my drive and shared drives is the same one as you have in your Google Drive. Um, for me, all these folders, so DSCamp 2025, I have all these files. And then it's straightly showing what my drive has. And it's mounted on this Google Colab. So the path will be content drive. This will lead to my Google Drive, and then it's gonna follow all these follow steps. If you guys are trying on your own with the Google Colab in the future, you would have to change these paths. But I'm gonna use it for me. This is the right path. So we see this is a tree, diabetes. um, Okay, so this is another decision tree data, so this is kind of different. But for us, we're gonna use the diabetes data. Let's see what it has. We do df.head, see the pregnancies, I guess it's the months, glucose, blood pressure level, skin thickness, insulin level, BMI, and age and diabetes, and we have an outcome, which is 1 and 0. We say that because this is a diabetes data, we'll say, okay, so this person has a diabetes, this person doesn't have. And then this will be the label, and all other columns will be the features. Okay, so we understood the data, we know what it has. We're gonna use, um, we're gonna create an algorithm right now. Let's see. So this one does featured columns, glucose, insulin, and BMI. So it's kind of like I said, if you understand what this data is, and if you know beforehand what features might cause the diabetes, like say if you're a doctor, then you know what it is. So you can take out only the ones that you think is important and then go ahead with it. In this case, we only choose glucose, insulin levels, and BMI. So we divide them into features and labels by calling the column feature columns that we created here. And then we pull it out from the DF. And then we create a Y value that is outcome. So outcome column here, and then we use it as target variable. So we've split into 70% and 30%. Like I said, we do this for the cross validations. We we have a train set, test set, Y train, Y test. So this is usually how it goes. You can always change the name of the variable, but this is very commonly used. If you're creating a lot of different algorithms in the same file, then you can just say like diabetes or diabetes. And then you can differentiate between them, but just be sure that you put the right variable in the right places. So in a random state, the numbers can be anything. The sets will change as you change the random state, X, Y, and then the train test split is a function that we pulled from the sklearn model. And then you put the X and Y, and you said test size is 30%. So other 70% will be a training set. I run this. Okay. So we use a decision tree classifier. The criterion is entropy. It's a deeper concept. So for now, entropy is good. Max depth is how many steps there are. And then like here, you can specify these, or you can just skip them and use it as it is. But it is specified here. So we're creating a decision tree classifier. We're creating a base algorithm here. And then we're gonna train it using our own data. X train and Y train. So CLF was the classifier here, and then we fit it into the model. So we can overwrite it back to our original CLF because that's gonna be our own model. And then it's gonna predict the response. Okay. And then we're gonna test the accuracy. I said there is a lot of methods that see evaluate our models. In this case, we use the accuracy score. How often is the classifier correct? So we created a data with 70%, and then we're testing it with other 30%. So we can get the accuracy because with the testing data, we know what the result is. So we compared the predicted data and the predicted result and the actual data. So it says accuracy is about 76%. And then we tested and then it's about 77%. So not bad. 77. It depends on how accurate you need to be. Maybe it's not good enough for the diabetes because you really need to know if the person is sick or not. You can try like various other features too. Um, age, income. Yes, this is not important. This is for trying other like bank loan model. We can like add more features. like pregnancies. Okay, and try again. I guess doesn't really matter. And we can put in other features too, and then try again and see if it's better or not. Okay, now we're trying to visualize the decision tree. These lines, if you didn't install the libraries, then you might need it. If you did, um, they use this here? Not really. Oh, so they use this one. Maybe not this one, but if it causes an error, just install the libraries and then try it again. Then you might get the right results. So this is a decision tree we created, kind of simple. Um, if it's glucose, is the glucose level less than 127.5? If it's true, then you go to the left side. If it's false, you go to the right side. And then you kind of follow the steps, then it's gonna lead you if it's class 0 or class 1. So this is example of a decision tree, and you're getting a result as it is. There's other methods of evaluating features too. In this case, um, they use the chi-square. Um, this may be a little bit complex, so you can skip this if you want, or you can just read this article here and then try to understand what this tells you. So the basically it's doing the same thing. Um, sorry, it fits X and Y, and then gets the score. Here too, feature importance is gonna evaluate which features is the best, is important. Um, so I don't think I need to. I'm gonna go deeply into these, but you can study more on the extra tree classifier. It's just an extra step on evaluating things. So you just need to know that these kind of methods are exist. And then here's correlation. Correlation, you reuse it very often to see which features are correlated to each other. Um, as the color gets more greener, it's more related to each other. So I guess here 0.54 is the highest here. So age and pregnancies are highly related. Outcomes and glucose. So in this case, it will be more important to see the outcome and other features. So glucose level, BMI, and age. I guess these three are the key factors for the outcome of diabetes. Okay. Any questions on the decision tree? Okay. Let's try. Now let's try the linear regression. Same. You don't need to install the libraries if you already have. Please do if you didn't yet. Importing libraries. Same here. I'm gonna mount the drive first. Okay. And then I'm gonna do the read CSV on the salary data that we have. Years of experience and the salary. 1.1, this much. 1.3, this much, and those. Okay. So data processing. In this case, it used the iLog. Um, I'm pretty sure you guys did it in the last classes. You're getting all the datas here and then there. And then if I print it, it's gonna give you an array. Or you can just do X. X on the same array and all these number points are there. Now, same, we did a splitting the data. It says 1/3, which is same as 0.3. And then we examine each variable. We see X train here. Same here. X test. And then Y train, Y test. It's gonna look the same, just different numbers. Now we fit the regression model. Linear model, linear regression. We import from sklearn. Here we go to regressor and then regression. If you go into the sklearn site, it's gonna have these sample codes. So you just need to copy and paste them and then put in the right model, right name, and all the stuffs. It's pretty much straightforward. All these words will be the same, all the variable names will be the same. So you just need to put the right data and then in the right situation. So I fit it. Okay. Now the regressor has been fitted. Now I'm gonna predict with the X test. And then this is predicted. And then this is the actual test. Somehow the numbers are showing like that. So I predicted, I guess it's predicted by the model. It's showing the numbers differently as it is. Yeah, I think they just disregard this part. Just look at the number here. So our predicted number is 40,835.11, but actual value is 37,731. And then you can just compare how much different they are. And then it's kind of following the tendencies, but not that accurate and number wise. So here we're gonna plot it in a graph like this. So scatter plot, X train, Y train data points. So we're gonna put in as color red. But then we we use the predicted line over here. And then we title it, label it, show. And then we're gonna create another scatter plot with the test, PLP scatter plots title, same thing. Just put the title name versus here, and then X label, Y label, and show. So all these steps are not much a difference with just plotting scatter plots. And then the result shows like this. Training set, point, we get the middle line that goes through this as much as possible. And then there. Okay. And testing set, we see, yeah, pretty much the same. Different value, you just put in one and you just see what will the result. So if you put 1 year, and then this will be your salary. So because this data is very limited and then it doesn't have a lot of features, so it's very simple, and then the result also shows good. But a lot of cases there's outliers that goes here, like 1 year experiences, you make 120,000, which is very rare. So that will be treated as outliers too. Or maybe you don't treat it as outlier. You find it reasonable and then you just keep those. That's gonna alter the result a lot. So be careful on what you treat as an outlier and what you don't treat as an outlier. It's more of a statistics um matter here. And then that. So um pretty much the same with the decision tree too. You get your model, you import your model, you declare it, you train split by 70%. 70% is usually good. Sometimes you do 80%. It really depends on your choices. Um, and then you create a model, you put into the algorithm, you fit it, and then you create a result with your test data. Decision tree two, you split it, you put in a classifier, you fit it, and predict. Steps are the same. It's only the models are different. So let's try here. Sorry. Um, you don't need this. This KNN classification is a K nearest the neighbors. It's commonly used too. If you're interested, you can try to look it up for the nearest neighbors. So basic idea is you're finding the nearest neighbors among the groups. So if you have one point, you find the nearest neighbor, then you another point, you find the nearest neighbors. And then see if it's in the same group or not. In this case, we do the sklearn neighbors, matplotlib, same importing the libraries. In this case, we created a function that gets the data because we're gonna try with different neighbors. And then data class, data xy, neighbors, k neighbors, classifier that fits xy, and then all these. So you put the data and then k and in the function to run it. Okay. So we have a different data set options. There's a linear outlier. Let's say I myself doesn't don't know what these are. You guys can um check it by calling it here, or you can just go straight into the file and then have a look at those. For me, again, I'm gonna mount and then run it here. Let's see. Hmm, I don't think this is necessary. So this is a reading the file and then trying to look at it, but the line is different, so I'm gonna skip that. This is only for Google Drive, so if you're using the other files, that may not be necessary. All these here, yeah. For me, I'm gonna just mount it again. Takes few seconds. Okay, and then I run it. It's gonna take some time. Let's see. So this is the k nearest neighbors. Gonna create the results for 1, 5, 20, 30, 40, and 80. The concepts can be a little bit difficult if you go into the details. But for now, let's just see how you run these codes, and then that there's this kind of methods. The k-nearest neighbors are commonly used to, so I think it'll be good for you to um, try to look it up on what it actually does. And so KNN with k equals 1. So these are zeros, these are ones, these are zeros, and it's ones, all these. And you can see that it's slightly changing, or a lot of changes as the number goes. So here, this field has changed to orange. Now this field changed to 30, blue. So this is classified as blue. So this areas without the points is treated as blue, which is 0. Concert. Let's have a look at the data. They only have X and Y classes, so maybe it's just simple data just created for for the demonstration purpose. So at this point is 0, at this point is 1. So you kind of getting k nearest neighbor k is 80, then it kind of gives this kind of result. So this one also pretty much the same. You get the values here, you put it, then you get the results. Okay, any questions on these three? No, okay. So, I think it will be good for you guys to actually try this. Um, try these different models and algorithms. There's a lot of test data sets. I mean, the like demonstration data sets in online too. That's gonna help you try these algorithms. It's kind of fun to have a look at um how it works. If you change something, the result changes if it's correct or not. In a Kaggle, there's a famous classifying questions that um in a Titanic shipwreck um that they give you information of the passengers and then you predict the outcomes. You can also try that because it has been so famous. There's a lot of people get almost 100% on their models, but usually that's not the case. Um, there's to install the libraries, you can do the pip install. There's lot of methods. You can go to your Jupyter notebook directly and then do pip install like this. Try both ways with the exclamation mark. Without it, um, you'll see that it's gonna install. Or you can go to your for now, it's just try and then Jupyter notebook and then try to the pip install and see if that works for you. Okay, and then I'm gonna show you just one more thing. On our PPT, so these are the lines that we just went through. And clustering. So a little bit different here, I think, but we said that clustering is unsupervised learning, right? So we trying to get the group through this k-nearest neighbor. So with these points, they show the similarities, and then these areas will be treated as one of the group, and then this orange area is treated as the other group. But that's how it goes. Classification, this is a tree. Okay, so there's kind of fun things to do over here. Machine learning examples. Um, if you go into the link, actually try it. You're gonna see something like this, quick draw. Oh, that's okay. I don't know what exactly that is. Rock, maybe I don't know, like so it's reading my drawings and then trying to predict what I'm trying to draw. So it's gonna have a lot of data that people draw on how you draw something. People usually might think or something like that. So I think it's trying to predict the result by looking at my drawings. So this is kind of a game that you create with machine learnings. You have a lot of sample data that has drawings of a lot of people. Usually this is drawn by with our mouse. So it's gonna be just lines um and myself I'm not I'm not good at reading and drawing stuff. So but fortunately was able to uh read what I tried to draw. So this is something fun to do. Try other two too. Auto draw and that digital recognitions too. Um, you can go into YouTube and see how like generative AI are done right now. There's lots and lots of videos. Um, Reinforcement learning is also fun, especially if you like gamings. Um, they're using it a lot to simulate stuff and provide like a best solution for some kind of games. There's a famous one that has been done with the Mario. Try like Mario supervised learning or Mario reinforcement learning. It's gonna show you how they're teaching the machine how to clear the stages. So it keeps on doing over like hundreds games, five like thousands of trials, and they gonna find like a optimal path solutions to clearing the stage. So that's also interesting to watch too. So for the project, you have experience of, like I said, doing the object detections. Um, the complex part will be done for you, but your job, I guess your job will be labeling and then trying actually putting the data into it. So that's gonna be a lot of fun too. To be honest, labeling is kind of tedious job because you're doing it over and over again. I haven't looked at the project guideline yet, so maybe the labeling part can be skipped. It's already done to you. Um, if you're doing something like a past ones, some of them might have been done by me too, but it's gonna be fun too. So, if you have any questions, feel free to stay and then ask me. If not, I think it's good time to finish today.